here is our first question, question number 7. Let's try to answer this question now. As you can see here, first of all, the part A is simply asking us state the name and purpose of component X. So here is component X. Component X is here. So simply this is a very common type of resistor. This is called variable resistor, and its purpose is to change the resistance. Mean we can change the resistance of this resistor. And so that's all what we need to understand, and here is how we can write our answer. Variable resistor, it can vary or it can change resistance. When we change the resistance of the circuit, it means current in the circuit also changes. It is given to us the heater is designed to work from a power supply. Mean this is the voltage needed for the heater, and the power rating of the heater is also given, that is 4.5 watts. Now the question is asking us by considering the current in the heater. This is a hint for you, considering the current in the heater. So this is the hint, very important information for you. Calculate the resistance of component X when there is correct potential difference across the heater. So this is our heater. So the potential difference across this heater is 3.6 volts. So this is 3.6 volt. Its power rating is also given to us, but don't get confused with the voltage of the power supply. We need to consider voltage across heater when it is operating normally. So now simply first thing we need to find current in the circuit, and then we can use that current in the circuit to find the resistance of variable resistor. Let's try to see how we can answer this. And so this is how we can answer this question. So first of all, what we have done, we have calculated I. So you can see current, so we have calculated, and this is for heater. So our answer is 1.25 amps. So now when this switch is closed, so current in this circuit is 1.25 amps, and same current is passing through this resistor, same through heater, because they are connected in series. So what is the voltage across component? And this one is the voltage across heater. So I will simply say this is V for heater. So now we have V for heater, and the total voltage, this is the EMF of the battery, or the total voltage across battery, and we got this is the voltage across X component. I will simply say this is Vx. Now we have Vx and we have I. Simply we can calculate resistance of X component. So here is resistance of X component. Now let's move on to part C now. Sometime after the heater is switched on, the ammeter reading has been decreased. Ammeter reading has been decreased. So you can see if the reading of this ammeter goes down, what can be the reason? There are two possibilities, because this current in the circuit, I will say that I total is depending on two things. One thing, it is depending on the total voltage, mean EMF of the battery. We can also write down this is the EMF of the battery. Or it is depending on R total in the circuit. So this can go down or this can go up. So if you have understanding of this, then simply we can answer. So first thing, the battery running down means EMF decreases, as I mentioned here, or resistance of heater increases. That's all. This is how we can answer question number 7. Next one is question 8. Is quite interesting question. This is based on logic gates. Question number 8. First thing we need to understand is that the name of these logic gates. The name of this logic gate is NOT gate, and this gate is AND gate. AND gate. So these two names are very important. And here we have relay, and next one is lamp. So we need to complete the table by giving the outputs of A and B. So outputs of A and B are given. So let me little bit explain to you about NOT gate. For example, if the input of NOT gate is 1, its output will be 0. If its input is 0, output will be 1. And for AND gate, if one input is 0, another input is 1, output will be 0. If both inputs, let's say this one is 1 and the other input is also 1, then in that case, let me again write down, maybe the second part will be hard to see. Let me write down, if this input is 1, this is also 1, only its output will be 1. So this thing we need to understand. Now let's move on to next one. What is given in the question? That is very important. We have to be very clear. So many students, they will miss this point and they will get confused what's going on. Even they understand NOT gate and AND gate. So it is given to us the output of temperature sensor. Output of temperature sensor is logic 1 when there is a high temperature, raise in temperature, and output of light sensor is 1 when it detects raised light levels. Output is 1. And so based on this, we need to answer output of A, output of A and output of B. So the output of A, for example, this is the first thing we have to be quite clear. So let's try to understand. I no need to write again and again, so you can see from here. So output of light sensor. If the output of light sensor is 0 and here output is 0 here, if this is 0, so it is NOT gate, this has to be 1. So that's the reason we wrote here this is 1. Now the next thing what we need to understand is, if this is 1 and this one is 0, what is the output? That has to be 0. Next thing, when output of light sensor, this is 0, so this again has to be 1. This has to be 1. Now when this is 1, that is also 1, means when this is 1 and here is also 1, so this has to be 1. And same as when this is 1, for example, this is 1, here has to be 0, so this is 0. And the next one, so we see we have these two, 0 and 0, mean this one is 0, this is also 0, so this will be 0. And the last one is 1, so the output, if this is 1, this has to be 0. And here is 0. Now we need to consider these two now, 1, 0. So means when this is 1 and this is 0. So the output has to be 0. So here is what we got, output of B. I hope it is quite clear to you now. Next part is simply asking us, state the condition under which the lamp is lit. Dark. If dark, the output of this one, output is 0. And when this is bright, output of light sensor is 1. And when temperature outside is cold, output of temperature sensor is 0. And when it is hot outside, means the environment is hot, output of temperature sensor is 1. This lamp has to be on, simply speaking, when output of B is 1. So how this output can be 1? This is only possible if this input is 1 and this input is also 1. As we know, here is a NOT gate, so this input has to be 0. So simply we can say it has to be dark and hot. So that's the reason our answer is dark and hot. Suggest why B is connected to a relay. So we need to understand the logic. Let's say this is our circuit and relay is here. This is just a coil, and here we have circuit like this. Let me draw in a little bit different way so you can see the logic. And let's say here is a battery and here our lamp is attached like this. So this is low voltage circuit. and this one is high voltage circuit. High V, I will just write down. High voltage circuit. High voltage. B cannot provide enough power because this is low voltage circuit. Why? Because B is connected. So B is in this circuit. B is connected in this circuit. And this circuit has low voltage. So the voltage is not enough. So we use relay. So relay will switch on, and other circuit means relay will switch on high voltage circuit. So that is the simple reason, and this is the purpose of relay. This is how we can answer part C. Question number 9 now. Question 9. Question number 9 is asking us describe what happens to the charges in a metal point on a ball as the positively charged rod is brought. So we have ball is here. So this is the ball. I can highlight for you here. And this rod is positively charged. Means it has net positive charge. Means lack of electrons. So what will happen? Simply understand, if I draw this side, I can say this is positive, negative, positive, and negative. So these electrons, they will move towards this side. The side next to positive rod will be more negative. Net negative charge on one side and net positive charge on other side, because electrons will move from this side to this. So we have more electrons on this side. So this is what we need to say, that electrons or negative charges move towards positively charged rod. Explain why this happened. We need to explain the reason now, given that the ball is uncharged. Means uncharged simply means that it has same number of positive charges and same number of negative charges, or we can also say is neutral. So why this happens, here is the reason for that. Negative charges, for example, they are closer to the rod, and attraction between opposite charges is greater than repulsive forces between like charges. So what exactly it means? So simply means that this side, as we have discussed, become more positive and this side become more negative, and this rod was positively charged. This rod was positively charge. Now we need to understand the Coulomb's force or attractive force between charges. Now you see the negative charge is closer to positive charges. If we compare this one, the positive charges and positive charges, they are far away from each other. So this is force of attraction between opposite charges, and here is repulsive force between same or like charges. So in this case, force of attraction is winning. Force of attraction is greater than repulsive force because this distance is shorter than this distance, means the distance between same charges. So that is the reason. So the next question is very simple one, is simply asking you state the unit. Electric charge has this unit coulombs, and often we write down capital C because this is after name of scientist. So this is how we can answer this question. Question number 10 is about radioactivity, but this is a kind of combination of electromagnetism and radioactivity. So first of all, we need to understand if we have magnetic field that is into the page. So this symbol cross means that into the page. So the cross is telling us that magnetic field is into the page. So we can simply draw these arrows. Now, first thing we need to understand, if gamma particles are coming, gamma particle, so we simply understand this particle will just go in a straight line like this. Next one, we need to understand if alpha particle is coming. Let's say alpha particle is coming. I will just write down alpha particle. Now we need to use Fleming left hand rule. So what we need to use is Fleming's left hand rule. Fleming's left hand rule. Left hand rule. If we use Fleming left hand rule, so the force on alpha particle means the magnetic force on alpha particle, that will be upwards like this. And if we have beta particle, this has opposite charge, so the force on this one will be in opposite direction, somewhat like this. So we can see at A the number of counts are only 32 counts per minute, and at B their number of counts are a lot. Number of counts are a lot. And at C we can also see the number of counts are not too many, less than B. So this is when radioactive source is totally removed. So the readings, this almost stays same. So we can simply say these readings can be due to background radiation. So these counts are due to background radiation. So simply I will write down these are due to background radiations. Due to background radiations. B, you can see it dropped to this number, and this also dropped to this number. As there are readings at this point, it means the gamma particles are reaching this point. C, it means beta particles are reaching this point. So this is all what we need to understand, and is asking you deduce the type of emissions. So it means gamma and beta particles are present, and also radio means the background radiations also there. So we have to first of all deduce the type of emissions, radiations, and then we have to explain our reasoning. Our reasoning will be based on Fleming's left-hand rule and charged particles in a magnetic field. So let's try to answer how to write a final answer. And so here is how we can write our final answer. Gamma rays, as they don't have charge, so they just go in a straight line. Gamma rays are detected at B, as I explained to you before. They are detected at B because they are not deflected by magnetic field. Beta particles have negative charge, and they are detected at C, as here they are detected at C because they are deflected by magnetic field because they have charge. And the experienced force that is towards the bottom of the page means they go like this. So they go like this. This one is better one. So they go like that because the force on them is towards the bottom. So that's all. And at point there are background radiations. So this is point A. So only background radiations are detected here. So background radiations. Let's try to answer last question now. Complete the parts of these alpha particles. So first thing we need to understand, as this alpha particle is between them, it will go almost in a straight line. It is coming right on this nucleus, so it will bounce back, it will be deflected back, and this angle will change. So just we need to draw the straight lines. This is how we can draw. Let's move on to the last part of this paper and this question. Part B. Part B1. An atom consists of very tiny charged core. Means nucleus. Charged core simply means that nucleus. So this is what we call is nucleus. It contains almost all the mass of the atom. State the result of the experiment. Okay, so we need to state result of the experiment. Let's try to answer now. Because few particles are deflected back, so that's reason means the core is massive and it has positive charge because alpha particles are deflected by nucleus. So we can also say nucleus is positively charged. Next is asking you the charge actually. So as I mentioned before, as positive charges means alpha particles are deflected by nucleus. So we can say the nucleus is positively charged. So that's the reason we have written here the charge on core means on the nucleus is positive. State what occupies the space between these charged cores. So you can see here this is nucleus and this is also nucleus. Simply we can say empty space. So this is how we can answer our next question and the last one. So the last one is quite basic question. Is simply asking you need to find out number of protons and neutrons in alpha particles. So here the 2 is actually, this is called atomic number. 2 is called atomic number and this is equal to number of protons. Is equal to number of protons. So we simply write down number of protons. And the 4 is, this is actually mass number. This one is mass number. mass number. Simply this is equal to number of protons plus number of neutrons. So number of protons, quite straightforward, we can simply write down 2 protons. How about number of neutrons? Number of neutrons also 4 minus 2. So we can write down this one, we use letter Z. For mass number we use letter A. So we can write down here A minus Z will give you number of neutrons is also